Welcome back to part 2 of our Arduino Uno hardware overview. In the first part, we explored the microcontroller and how to use the digital input and output pins with real examples. If you missed that part, be sure to check it out. Today, we are diving deeper into the board's capabilities. We will be covering pulse width modulation, which is the abbreviation of PWM, the role of analog pins, okay, how serial communication works, and the power pins that keep your projects running smoothly. Okay, let's get started and unlock more of what the Arduino Uno can do. Going back to the PowerPoint presentation, as we reached in the last video, the digital input and output pins. Today we will continue in the digital pins part of Arduino board, explaining the term PWM, which stands for pulse width modulation. So what is a PWM? As a definition, it is a technique used to control the amount of power delivered to a device by varying the width of pulses in a signal, where pulses are toggled between high, which is on, and low, which is off. Okay, to understand this, in Arduino, on the Arduino board, PWM is used to what? To simulate analog output using digital pins. How does it simulate an analog output from a digital pin? First of all, we will go back to the definition of digital pin. A digital pin can only output two stages, as we said before. Either a high stage, which is on, okay, that represents the 5-volt signal, or low, okay, which is off stage, which represent the 0-volt signal. It's either fully on or fully off, nothing in between. Okay, now we will go to the definition of analog output. What is an analog output? An analog signal can vary smoothly between 0-volt and 5-volt. Okay, so here it comes the role of PWM. A pulse width modulation simulates this smooth range by rapidly switching the digital pin on and off in a cycle. Okay, by varying the duty cycle, an intermediate voltage is created. So you ask yourself, what is a duty cycle? It is the percentage of time the signal is on during one cycle. Okay, for example, a 50% duty cycle means the signal is on half the time and off half the time. Okay, the higher the duty cycle means more power is delivered, where for 75% duty cycle, the signal is on 75% of the time and off 25%. Okay, however, for a signal with a 25% duty cycle, the signal is on for 25% of the time and off for 75%, resulting what? Resulting in a lower power, like what? Like dimming a LED. So in our Arduino board, as you can see, the digital pins that support pulse width modulation are the digital pins that have this shape next to them. The pins are 3, 5, 6, 9, 10, and 11. These digital pins support pulse width modulation. Let's see pulse width modulation in action by dimming an LED using different duty cycles. Here is a practical demonstration of PWM. By varying the duty cycle, we're controlling the brightness of this LED. Okay, so let's turn it on. Okay. Notice how the LED dims and brightens. This is how we simulate an analog output using a digital pin, which is 9, that supports PWM. As a conclusion, PWM is a clever way to mimic analog behavior using a digital system, making it possible to control devices that require variable power levels. Now we will move on to the next slide. We will explain a new concept. We will talk about the analog input pins. Okay, as we can see on our Arduino Uno board, the analog pins are located from A0 till A5. We have 6 analog pins. What is an analog pin? Okay, analog pins on an Arduino are used to read continuous signals that vary smoothly over a range of value, unlike the digital pins, which only reads high or low. So the analog pins can measure a range of voltages from 0 volt to 5 volt. This allows the Arduino to sense varying levels of inputs, like what? Like light intensity or temperature rather than just on or off states. Input pins. Each pin provides a 10-bit resolution. Okay, to understand that, we need to explain the term ADC, which stands for Analog to Digital Converter. The Arduino converts the analog signal into a digital value using that ADC. Okay, what is an ADC? It is a function. Okay, ADC is a function in a microcontroller that converts as an analog signal which is continuous and varying into what? Into a digital value which is discrete and quantized. This allows digital systems like microcontrollers and laptops or computers to possess analog signals. We'll dive deeply in the conversion process. Okay, first of all, we have first step, sampling step. The ADC takes periodic samples of the analog signal at specific intervals. Okay, next step is quantization. Each sample is then mapped to a discrete digital value based on the ADC's resolution. Okay, we will talk about the resolution of the Arduino Uno ADCs. But first, let's talk about the third step, which is the digital output. The result is a digital number that represents the amplitude of the analog signal at the time of sampling. Going back to the term resolution, the resolution of an ADC determines how many discrete value it can output. It is expressed in bits. In Arduino, we have 10-bit resolution. Okay, how we calculate this? The number of levels equal to 2 power what? Power the resolution. So we have 2 power 10, we have 1024 levels. Okay, it varies from 0 to 1023, where 0 level represent 0 volt and 1023 level represent the maximum, which is 5 volt. So any value, any level between the 0 level and 1023 level, it represents a value which is between 0 volt and 5 volt. Resulting from what? Resulting from the sensors connected to the analog pins. It can maybe a temperature sensor, a light intensity sensor, and etc. and so on. It's always good to have a background in these concepts, but don't worry, things will get much easier and more interesting when we dive into practical examples and projects. Go to the next slide, talking about the serial communication. First part in serial communication is RX and TX pins, which are the 0 pin and 1 in the digital pins, as you can see in the slideshow. Okay, they are used for serial communication with computer or other devices. Okay, the RX pin stands for receive, Okay, this pin is used to receive data from another device, where TX stands for transmit. This pin is used to send data from what? From Arduino to another device. Okay, so later on we will dive deeper in these pins and how they work, showing how to communicate between two Arduinos and how to connect Arduino to a Bluetooth module. Okay, next point in serial communication, the board has a built-in USB to serial converter, making it easy to program and communicate with. Okay, okay, it acts like a translator between your computer and the Arduino. It converts the digital data sent from your computer's USB port into serial data that the Arduino can use and vice versa. Okay, going to the next slide, there are three more points to talk about in a brief way to finish the hardware overview of Arduino Uno R3 board. Okay, we have the first point to talk about is the reset button. As you can see on the Arduino board, we have the red reset button. It is a small push button on the board, allows you to reset the microcontroller, restarting your program from the beginning. Okay. The next point to talk about is the power and the ground pins. Power and the ground pins. The power pins you have, as you can see here in the slideshow, you have the 3.3 volt pin, 5-volt pin, and the ground pins. These pins are used to power external components or to interface with sensors and modules. Okay, third point to talk about is the built-in LED. Okay, the pin 13, the digital pin 13, is responsible for a built-in LED on this Arduino board. A small LED is connected to pin 13 that is useful for basic testing and debugging. That wraps up our hardware overview of the Arduino Uno. We have explored everything from the microcontroller to the various pins that power your projects. With this solid foundation, you are ready to take the next step. In our upcoming video, we'll dive into the software side, where you will learn how to bring your hardware to life with code. If you found this video helpful, don't forget to like, share, and subscribe to AutoCraft Studio. Thanks for watching and see you in the next one.